Okay, so here we have example 2, and I'm not going to lie to you. Example 2 is probably going to push you out of your comfort zone quite a bit, but I still want you to try it and just think about it before you go through and find the answer, before I tell you the answer. So I want you to really think about it. If you'll remember, this notation here represents cardinal numbers. So when that little n represents the cardinal number of set A is equal to 4, remember that means that A has 4 items in it. And this notation means that the cardinal number of B is 5, so B has 5 items in it. And then this notation means that the cardinal number of C is 6, so C has 6 items in it. They want to know what is the greatest and least number of elements possible in, and then there are 2 different sets. So I really do want you to try to think about what that means. Draw out some pictures if you can to kind of get an idea, and I want you to give it some good thought before you press play again and find the actual answer. So go ahead and pause the video now. Okay, so hopefully you've given that lots of thought. You may have even gotten frustrated and turned the whole thing off and had to come back to it again. And that's okay. I did want you to give this some serious thought. So we're going to be figuring out these 2 things. The first one is A union with B union with C. So they want to know what is the greatest and the least number of elements possible in this set. And this is tough because we don't know what the set includes. All we know is that A has 4 items, B has 5 items, and C has 6 items. So what we could be looking at is a situation like this where we have our set A, our set B, and our set C, and they could, all be meeting together. So that in just one spot, that's highly possible. But it's very possible that these 4 items in set A are only in A, and these 5 items in B are only in B, and the 6 items in C are only in C, and there's nothing that overlaps. That's very possible. In that case, we would actually have the greatest number of elements possible. So in this case, we would just add them all up, and that would give us 15. So the most amount of elements we could possibly have is 15. So I hope that you did some drawing on that and kind of figured that out. Now, for our least number of items, well, here I hope we had to do some thinking. And if if um, if for some reason these didn't necessarily just overlap, but what if they were concentric circles? Like, for instance, what if this was circle A, and this was circle B, and this was circle C? Well, in that case, we would have 4 items in A, 5 in B, which would give us 1 more just for B, and 6 in C, which would give us just 1 more for C. So the least number possible in the union, where you're joining all of those sets together, in this case would be 4, 5, 6, because the union would be all of them joined together, so that would be the outside. So our least number of elements possible is 6. Now, I don't know how you feel about that one, but I think it's pretty interesting and it's a good thinking problem. So don't get frustrated and upset. We're thinking our way through these. Okay, so now we have this one and we're talking about intersections. So we have A intersected with B intersected with C. And we want the greatest number possible and then the least amount possible. So let's say again that we had those concentric circles again. So if we had A and we had B and we had C. Well, remember, A, there were 4 items. In B, there were 5, so that leaves one more plus 4 to give you 5, and one more in C to give you 6. So our greatest number for the intersection where all 3 of these intersect would be right here at A. So that would be 4 items. Now they want to know the least number of items that they could have, the intersection could have in common. Well, what happens if the circles don't meet and touch at all? What if you have A, B, and C over here, and A has 4 items in it, and B has 5 items in it, and C has 6 items in it? Or it could even look very, very similar to what we had originally drawn in, where they did actually meet, but in this case none of the items overlapped. Well, in that case, our least number in the intersection would be 0, because we wouldn't have anything in common at all in this situation. So I just wanted you to really think about those.